Assalamualaikum and very good morning. I bid to everyone. Today we from Group 14 will present about hydroxide for first row transition element. So in this group we have Shannon Krishnan who will give a presentation on first three element in transition element, followed by me, Nur Shafati Shahira, will present about next four transition element, and lastly Razita who will present about last three element in transition element. So without further ado, I will pass to Snehan to present his slide.
Let's start with scandium hydroxide. It is also known as scandium trihydroxide. It is a white powder. Scandium hydroxide is an amphothree compound that can react both as an acid or as a base. This compound has a lower oxidation state, which leads to the more metallic behavior. It precipitates at pH above 4.8 and dissolves in excess alkali to give tetrahydroxoscandate anion. It is insoluble in water and mineral acid. The thermal decomposition of scandium trihydroxide to produce scandium trioxide and water. This reaction takes place at a temperature of over 460 degrees Celsius. Besides that, scandium hydroxide reacts with alkali to produce scandium ion. We can extract scandium hydroxide by reacting scandium salts with alkali hydroxides. For an example, scandium trichloride reacts with sodium hydroxide to produce scandium hydroxide and sodium chloride. Other than that, we can produce scandium hydroxide by dissolving scandium in water, forming scandium hydroxide and hydrogen gas. We can extract scandium hydroxide from tungsten steel slag. The The method includes the steps. Firstly, using a fine ball mill to crush the steel slag prior to performing main process of inorganic acid leaching, organic solvent extraction, oxide precipitation, and the like, and enabling scandium in the tungsten steel slag to leach by the aid of sulfuric acid. Secondly, allowing leaching liquor to stand to precipitate titanium sulfate, filtering and removing titanium sulfate, diluting mother liquor by slag washing water, and using the diluted mother liquor as feed liquor, one of the extracted scandium. Thirdly, dissolving the filtered titanium sulfate solid by the slag washing water and using filtered with insoluble impurities as feed liquor 2 of the extracted scandium. Fourthly, extracting the feed liquor 1 and the feed liquor 2, performing back extraction for a loaded organic phase by NaO solution and using sulfuric acid to dissolve hydroxide obtained after back extraction. To titanium hydroxide. This compound is solid at STP. It is a base. At first, titanium hydroxide is an alkali. It is insoluble in water. Titanium hydroxide reacts with acids to produce titanium 3 salt. For an example, hydrochloric acid reacts with titanium hydroxide to produce titanium trichloride and water. When heat is supplied, titanium hydroxide decomposes into titanium trioxide and water. Titanium hydroxide is used as secondary building units in metal organic frameworks. Titanium hydroxide can be extracted by primary reaction product of titanium titanium 2 oxide plus water to produce metatitanic acid using transpiration technique at high temperature. Besides that, we can extract titanium hydroxide by using adsorption method. A sample of East Rosetta beach ilmenite concentrate was used in the present work to prepare the working titanium hydroxide assortment. The beach ilmenite sample was first grinded, then leached with hydrochloric acid under the following parameters. The leach liquor was subjected to liquid or liquid extraction using topo followed by 0.25 molar hydrochloric acid stripping after being filtered. For about 2 hours, some seed nuclei of titanium 4 hydroxide were added gradually and shaped with the stripping solution to prepare the titanium hydroxide, and the hydrolysis reaction can be represented as follows. Titanium tetrachloride react with water to produce titanium 4 hydroxide plus hydrochloric acid. Move on to vanadium hydroxide. Vanadium hydroxide is insoluble in water and usually first dissolved in sodium hydroxide solution. The solution can be reduced using zinc and acid, either hydrochloric acid or sulfuric acid. The chemical properties of vanadium hydroxide is vanadium trichloride reacts with lithium hydroxide to produce lithium chloride and vanadium trihydroxide. Besides that, vanadium trihydroxide reacts with hydroiodic acid to produce vanadium triiodide plus water. Vanadium hydroxide is used in SCR catalyst. SCR is a proven advanced active emission control technology system that injects a liquid reductant agent through a special catalyst into the exhaust stream of a diesel engine. Vanadium hydroxide used in this catalyst to yield more tungsten. We can extract vanadium hydroxide by reducing action of hydrogen in presence of vanadium and sulfuric acid. This will produce vanadium sulfate, that is sulfuric acid in which the equivalent quantity of hydrogen is replaced by the vanadium. When ammonia or caustic potash is added to the lavender solution, a brown color precipitate, which is vanadium hydroxide, is formed, and this is instantaneously absorbs oxygen.
So now I would like to present about chromium 3 hydroxide, manganese 2 hydroxide, iron 2 hydroxide, iron 3 hydroxide, and cobalt 2 hydroxide. So firstly, let's have a look on chromium 3 hydroxide, which have molecular formula CrOH3. So firstly, I would like to talk about chemical and physical properties of this compound. So in nature, it exists as green solid and it also dissolves in strong alkali and acid. So picture below is shown as the color of chromium hydroxide in solid or powder. So next is the uses of chromium 3 hydroxide. This compound is used for color material which known as pigment and also it react as a catalyst for organic reaction. Next, I would like to talk about synthesis of chromium 3 hydroxide. In order to produce chromium 3 hydroxide, we need to react transition metal salt with strong alkali. So for this example, I use chromium 3 chloride react with sodium hydroxide in order to form chromium 3 hydroxide with sodium chloride. So by doing the experiment, we can find that gelatinous precipitate is formed. This precipitate is referred to the chromium 3 hydroxide. Secondly, I would like to talk about manganese 2 hydroxide, which have molecular formula MnOH2. So the chemical and physical properties of this compound, it has white solid, which shown as picture below, and it also insoluble in water and it has melting point at 1945 degrees Celsius. So in order to form or produce manganese 2 hydroxide, we need to react uh, manganese ion solution with sodium hydroxide in order to form an manganese hydroxide. So in this experiment, we can find that white precipitate is formed, and white this precipitate is referred to the manganese 2 hydroxide. Next, I would like to talk about iron 2 hydroxide, which have molecular formula FeOH2. So the chemical and physical properties of this compound is, in nature, it exists as white solid and it's also poor soluble in water. So the uses of iron 2 hydroxide is uh, as air care product. So next is the synthesis of iron 2 hydroxide. So in order to form iron 2 hydroxide, we need to react iron 2 and hydroxide salts. For this example, I use iron sulfate react with sodium hydroxide in order to form iron 2 hydroxide with sodium sulfate. So as observation, we can observe that green precipitate is formed. This green precipitate form is referred to the iron 2 hydroxide. Next, we have iron 3 hydroxide which have molecular formula FeOH3. So the physical and chemical properties of this compound is it appears as vivid dark orange crystal which as picture shown below. So that was the color of vivid dark orange. Next is the melting point of this compound is at 135 degrees Celsius, and this compound also known as ferric acid. So next is the uses of iron 3 hydroxide. It used as aquarium water treatment and also used in production of cosmetic and tattoo ink. So in order to produce iron 3 hydroxide, we need to react with iron 3 chloride with sodium hydroxide. So as equation shown below is iron 3 chloride react with sodium hydroxide to form or to produce iron 3 hydroxide and sodium hydroxide. So in this experiment, we can observe that brown color precipitate is formed, and this brown color precipitate is referred to the iron 3 hydroxide. Lastly, we have cobalt 2 hydroxide which have molecular formula COOH2. So the chemical and physical properties of this compound is it appear as rose red powder which as the picture below, and it also soluble in acid and ammonia. So the uses of cobalt 2 hydroxide is used as a drying agent for paint and ink. It's also used as catalyst in the preparation of another cobalt compound and also used as manufacture of battery electrode. Besides, cobalt 2 hydroxide can be produced by react with cobalt 2 ion solution with alkali metal hydroxide. So in this experiment, we can see that cobalt 2 hydroxide is formed with sodium ion. So we can see that the precipitate is formed. We can observe that precipitate is formed. So the precipitate form is referred to the cobalt 2 hydroxide.
Okay, hi guys, I'm Razita. Now I'm going to continue to talk about last three first row transition metals, which are nickel, zinc, and copper. First, I will talk about a synthesis of metal nickel with iron hydroxide. This synthesis will form a chemical formula which is nickel 2 hydroxide. This compound is a green crystalline inorganic compound that produces toxic gases upon heating. It is also known as carcinogen and can increase risk of developing lung and nasal cancers. When we expose to this compound, it can cause a severe dermatitis, skin, and asthma. Metal nickel can be synthesized with two solutions that composed of iron hydroxide, which are aqueous ammonia and sodium hydroxide. These two solutions will react with metal nickel and form a precipitate of green gelatinous. Picture shown that a formation of precipitate green gelatinous. Chemical and physical properties for this compound are: it appears as a fine green powder. The melting point for this compound is at 230 degrees Celsius. It can be decomposed at this temperature. Other than that, It can also ignite in air at about 400 degrees Celsius. It's slightly soluble in water, but soluble in dilute acid and in ammonia. The uses for this compound are it can be used to make batteries. It also intermediate in the manufacture of nickel catalysts. Nickel catalyst plays role in many synthetic transformations. It used wide in industrial application. Next, it also can be produced to make hydrocarbon fuels. Cellulosic feed materials are a production of conversion high yields. Lastly, it also can be used as a catalyst in any chemical reaction. Next metal is copper. Synthesis of metal copper with iron hydroxide will form a chemical formula of copper 2 hydroxide. This compound is a pale blue solid and acts as a weak base in aqueous solution. A metal copper can be synthesized with two solutions, which are aqueous ammonia and sodium hydroxide. This solution is composed of iron hydroxide. When copper 2 ion reacts with aqueous ammonia, a precipitate of light blue will form. Same with when it reacts with sodium hydroxide. Picture shown that a precipitate of light blue are formed. The chemical and physical properties for copper 2 hydroxide are it appears at blue color, a blue to blue-green gel or light blue crystalline powder. Can be decomposed at melting point, which is at 80 degrees Celsius when it loss of water. It can be soluble in acid solution, concentrated alkaline solution, in ammonium hydroxide, and in aqueous ammonia, but it insoluble in organic solvents. The uses for this compound can be used as a battery electrodes in manufacture of rayon. Other than that, it can act as a mordant in dyeing, as a pigment since it is appear at a blue color. Lastly, it can act as a fungicide against bacterial soft spot called Erwinia on latex. Last metal in first row transition metal is zinc. Synthesis of metal zinc with iron hydroxide will form a chemical formula of zinc 2 hydroxide. This compound is an amphoteric hydroxide which can react with both bases and acids. It also is an insoluble hydroxide which reacts with strong acids and gets dissolved. Zinc also can be synthesized with two solutions which are aqueous ammonia and sodium hydroxide. Same with other metal. When it reacts in aqueous ammonia, zinc 2 ion will react with aqueous ammonia to form a precipitate white gelatinous. Same with when it reacts with sodium hydroxide. Picture shown that precipitate of white gelatinous form. Physical properties for this compound are it is an odorless compound, it forms a dull white precipitate and slightly soluble in water, but it is insoluble in alcohol. Chemical properties for this compound are when aluminum reacts with zinc hydroxide solution, it gives a white precipitate which is soluble in excess of the reagent to form complex aluminum hydroxide. It indicates the presence of aluminum. When zinc cations react with hydrogen sulfide in the presence of ammonia and ammonium chloride, it will form a white precipitate of zinc sulfide which is soluble in acids. The uses for this compound is it acts as an absorbing agent. It can be used in medicine and can be utilized for careful dressings where can work as a retentive, which is a bandage. For your information, the bandage that we use are utilized for post-medical procedure. It is covered with the zinc compound for engrossing the blood from the injury. Lastly, it can be used as an intermediate for commercial production for pesticides and pigments. So that's all from our crew. Before we end this presentation, I would like to show you guys videos for transition metal when it reacts with a hydroxide.
Today I'm going to talk about the reactions of transition metals. That's the top group here, going across here. First you need to know the colours of the transition metal complexes. Chromate 3+ is violet, CrO4 2- is yellow, Cr2O7 2- is orange, manganate ion MnO4- is purple, the cobalt ion Ca2+ is pink, Fe2+ is pale green, Fe3+ is yellow, and copper Cu2+ is blue. I'm going to show you some reactions that form with the complexes. This is copper 2, and we're going to add ammonium hydroxide. You get a pale blue precipitate forming, which dissolves when you add it in excess. We're now going to look at another complex that copper can form, this time with concentrated HCl. As you can see, when I add the concentrated HCl, this turns to green, which shows the different ion that's been formed. This is the octahedral complex, COH2O6 2+. When you add concentrated ammonia to it, it changes into the tetrahedral complex, COCl4 2-. And you also see a blue colour change. Finally, we're going to look at some reactions of transition metals with sodium hydroxide. First, we're going to look at chromium. On addition of sodium hydroxide, you get a grey-green precipitate forming. This will dissolve in excess to form a dark green solution. Next, we're going to add sodium hydroxide to iron 2. This time you get a gelatinous green precipitate forming that looks like seaweed. On further addition, it does not redissolve, but if you leave it for a little while, you will get it going a little bit red-brown as it oxidises in the air. Fe3+, adding sodium hydroxide, you get the rust red-brown precipitate. Again, this does not resolve on further addition. Finally, copper, you get a blue precipitate forming. Again, there is no further reaction when you add more.